Section 723, Day 1 is titled Applications of Probability. We are going to answer the question, how can I pull it all together? So question 98 says, in a recent survey of college freshmen, 35% of students checked the box next to exercise regularly. 33% checked the box next to eat 5 servings of fruit and vegetables a day. And 57% checked the box next to neither. First thing they want us to do in part A is to create a two-way table to represent the situation. Include your rows and columns. Can you close your Chromebook for right now? Thank you. All right, so on your two-way table, you're going to have a column for exercise and a column for do not exercise. You're going to have a row for eats fruits and vegetables and a row for does not eat fruits and vegetables. They tell us in the question that 33% of the people exercise regularly. We're going to write that as a decimal, so we're going to write it as 0.33. And they tell us that 57%, oh, did I miss something? Oh, that was 35%. Sorry, I'm messing it up. 35% checked exercise regularly. Sorry, that's down here. We're going to change that to a decimal. And 33% eats fruits and vegetables. We're going to change that to a decimal of 0.33. And then 57% checked the box next to neither. So they do not exercise and they do not eat fruits and vegetables. So in that corresponding box, we're going to write 57% as a decimal, so 0.57. We know that the outside over here needs to add up to 1, which is 100%. And we only know the 33, so we're going to subtract 1 minus 0.33. And that tells us that this row should combine to get 0.67. Same thing along the bottom. We only know the 35 right here, so we need to subtract that from 1. That's how we get the 0.65. We know this box is 0.57, and this box and that row is that column is supposed to add up to 0.65. So if we start with the 0.65, subtract the 0.57, that gives us the 0.08. We know this row needs to add up to 0.33. So we're going to subtract the 0.08 that we know. That gets us the 0.25. And the only thing left would be this one, right? So we start with the 0.35, subtract the 0.25, that gives us the 0.10, okay? So you're going to do mostly subtracting or adding depending on what they give you and what they don't give you to fill in on your two-way table. If you don't have your own handheld calculator, use the Desmos Scientific to deal with those decimals, okay? Question B says, what is the probability that a freshman in this study exercises regularly and eats 5 servings of fruits and vegetables each day? Okay? So we go to the column that says exercise. We find its intersection with the row that says eats fruits and vegetables. We've got 0.25 there, so as a percent, that's 25%. Question C says, what is the probability that a freshman in this study exercises regularly or eats 5 servings of fruits and vegetables each day? So we've got the 25% for exercising, the other 10% for exercising, and then for the eats fruits and vegetables, we already have this 0.25, so we don't have to write it twice, but then we also have the 0.08. If you add all 3 of these decimals together, so 0.25 plus 0.10 plus 0.08, we get a decimal of 0.43. So we're going to multiply that by 100 to get our percent of 43. You can also use the addition rule for that problem, but I think the top way is easier. Okay. Question D says, do you think that freshmen who eat 5 servings of fruit and vegetables per day are more likely to exercise. In other words, are exercising and eating associated? According to this, you would say, yes, they are associated. They are not independent of each other because they do not equal each other. So if you just look at exercising, students or the freshmen that exercise is 35% versus exercise would be 25 out of 33. Those are not equal. 0.25 divided by 0.33 is definitely not equal to 0.35. So they are associated with each other. All right. Any questions on page 20? Anybody still writing? All right, we'll give you a second to catch it. Question 99, which is titled Double Spin. So it asks us to remember the double spin, the game at the fair from chapter 3. The player gets to spin a spinner twice, but only wins if the same amount comes up both times. The $100 sector is 1/8 of the circle. Nick is currently playing the game. You're going to draw a diagram to show the sample space of every possible outcome for 2 spins. Okay? So it looks like, oh, if I spin a 10 and then I spin a 5, I would get a 10 and a 5. But no, that's not how this game works. This game only works if you spin the same amount 2 times in a row. So you would have to spin a $10 and a $10 in order to win. Or you would have to spin a $5 and $5 to win. Or you would have to spin a $1 and a $1 to win. Or you'd have to spin a 100 and a 100 to win. If you have 2 different spins, you don't win anything. Okay? So you're going to fill this table in your groups of 4. Leave your answer as a fraction. If your multiplying skills are not super great, you're going to use your Desmos scientific calculator to help you multiply. Okay? For instance, if you're filling in the very first box for the $100 and the $100, you're going to multiply 1/8 times 1/8. Anybody know what 1/8 times 1/8 would be? One what? Not 1/16. That's when you would be, that's if you add the denominators. We're not adding, we're multiplying. So what's 1 times 1? Wow. Let's try that again. 1 times 1 is 1, okay? Then for the denominators, you would multiply 8 times 8. What is 8 times 8? 64. So in the very first box, you would write 1 over 64. Write that right now. 1 over 64. In your group of 4, you are going to fill in the whole table. Okay? Again, you are not excellent at multiplying, which some of you are not. Then you're just going to use your Desmos scientific calculator, and it'll give you nice, pretty answers. Okay? For part B, it wants you to calculate what is the probability that Nick wins. Okay? Now, you only win if you do what? Spin it and get the same dollar amount, right? Only the ones that you get the same dollar amount would be winning. Okay? So you look at the chart, you see, oh, if I spin a 100 and a 100, I could win. Or if I spin a 1 and a 1, I could win. If I spin a 10 and a 10, I could win. So it's going to end up being all the diagonals added together. In order to add fractions, you need to have what kind of denominators? Same common denominators, right? So if your denominators are different, then you need to make common denominators before you add those fractions, or use Desmos, and it'll kind of calculate it for you. Okay, question C says, when Nick comes home from the fair, he tells Zach that he won the double spin game. Knowing that Nick won, what are the chances that he won $100? Okay, because he doesn't say how much he wins. He just says that he won. Is it really exciting to win $1? Not really. Is it really exciting to win $5? Maybe. Is it exciting to win $10? Yeah, $10 is nice. Is it exciting to win $100? Yeah. You know, if you win $100, that's kind of pretty good for this game, okay? So they want you to say, what are the chances that he won $100? Because then you would be super happy for him, okay? Question D says, a mathematical way to express the conditional probability relationship is the probability of A given B equals the probability of A and B over the probability of B. This relationship is called the multiplication rule. Verify your answer from part C using the multiplication rule, meaning you should get the same answer for part D as you did for part C, because you're verifying it. So it's just going to show a second way to get the same answer. All right.